Notes 8B, Super Mario Brothers. Objective, I can make predictions using numerical data. Essential question, how can I use technology to build equations to make predictions? On this slide, go ahead and watch this video right here. Where does Mario land? Drag the icon on where he would land here. How many points will Mario get on this jump? Pick a number between 100 and 4,000. Type a number on this slide. So if it was right here, what score would that be? Write that out. Using a ruler, measure how high Mario's hands reach. Record the heights in the table. Make sure you say if it's inches or centimeters. So record for 100, record for 4,000, and then how much is this one with the question mark? Click on the link to the Desmos sheet. On the Desmos sheet, type in the numbers that you got here. And type in the number you think that would be right here. Fit each linear, quadratic, and exponential model and estimate how many points Mario would earn. Once you do that, go ahead and pick a model for a final prediction. Which model do you think they picked for the points? Is it linear, quadratic, exponential, or something else? Circle the one you think it would be. Okay, now play this video and see what it was. Sequel. How high up the pole should Mario leap to make 1,000 points? Type your answer in either inches or centimeters. The model of those three functions that would best fit the point system would be quadratic. Go back through the Desmos simulation, see if you could determine that if you did not do so already. Let's go ahead and do an example for quadratic regression using the TI-Nspire. To find regressions on the TI-Nspire, you want to click Vernier Data Quest as the green beaker, copy the X and Y data into the table, click the graph to graph the points. You have to do that before you click menu. Then menu, for analyze, 6 curve fit, choose 2 for quadratic today. Enter and get the coefficients. Write your equation given the found coefficients. The area of a rectangle increases as the width measured in meters increases. The table of values below shows the total area AW for the corresponding width. Find a quadratic regression equation. So let's plug these in to our calculator. W will be our X value, our independent, and then A of W is our dependent. So let's go to the green beaker, click the table. Oh, there's a bunch of stuff there. So to clear that, you're going to press Control W, no. And then click it. And then we have our table. Let's type in our values. And then we're going to click the graph of the center at the bottom. The menu, 4 analyze, 6 curve fit, and then 2 quadratic. Okay, now we have all of our values. You may need to scroll down a little bit to see our determination coefficient. And then let's go ahead and record these on our paper. So this determination coefficient is strong. With quadratic regressions, we can't necessarily see a direction since, well, there's 2 directions there. We can only determine if it's strong or weak. So our quadratic equation would be y equals 6x squared, or in this case, w squared, minus 19w plus 30.5. Okay, it asks, what is the area when the width is 7? So we're going to evaluate here. And then it says, what is the width when the area is 36? We're going to solve this one. So let's go ahead and put those in the calculator. Let's go ahead and put it into Desmos. So to do the regression on Desmos, we go to desmos.com/calculator. Click the plus button, click table, type in your values. Okay, let's click the bottom box underneath the table. And to get the quadratic regression, we're going to type in y1 tilde a x1 caret 2, so x1 squared, plus bx1 plus c. And there's our regression from earlier. Now to evaluate when x is 7, we're just going to plug that in here. So we have a times 7 minus b times 7 plus c. And that's 205.5. And it's going to be meters squared. Okay, what is the width when the area is 36? From here, we're just going to type in y equals 36 and find where the graph crosses that. So we have this negative 0.267, but that's going to be extraneous because we can't have a negative width. So our answer would be 3.434. And again, the other number was extraneous. Because we can't have a negative width. How do you feel about today's topic? Drag the icon over how you feel about quadratic regressions. And then type your summary. What can quadratic regression models be used for? Type a response.